Catherine introduced me, I want to talk a little bit, kind of reaffirming what Catherine started out with. Why are there four-year degrees in engineering technology? There was a shockwave that hit the world in 1957. Up until that time, there were two-year ET degrees fulfilled mostly by the technical institutes and folks that were coming out of World War II that needed that next future of the American dream. 57, the Russians launched Sputnik, and America woke up. And it resulted in engineering programs having to become much more theoretically based in the mathematics and the sciences. And so there was that need for a more application-based laboratory curriculum to fill that gap that was left. That pathway and gap was fulfilled by engineering technology, and it also gave a pathway for the increasing number, as we've seen in Daniel's data, the increasing number of two-year engineering technology degrees, not being a dead-end path, but a start and a beginning to another career. There is a continuum model that's been put together by the American Society for Mechanical Engineering, and as you've heard, I'm an educator, so I have to talk with my hands. There's a lot of overlap in what they do. And we heard Werner talk about manufacturing. We look at engineering technology, distribution, sales, maintenance, production, manufacturing, but you start to see engineering coming into that realm. And so it's really how the companies fit and what they want to do. Where you look at engineering, when you get to the high end of the right side, you're doing much more theoretical research, much more complex design and analysis, which one of our former alumni will talk about that he is already doing. He's already into that mode of doing some of that advanced design and analysis. So we did a quick study that was presented at the workshop based on the knowledge, skills, and abilities for four-year engineering technology and engineering graduates. And if you look at the majority of the manufacturers that responded and employers, the majority were 63% said engineering technology graduates are better prepared to do applied work, while engineering graduates have a much more preparation in higher level science and math. The next largest group were 16.3% that said engineering technology graduates are better prepared to do applied work, while engineering graduates are better prepared to do design work. And then at the low end of the scale, 2.3% of the people surveyed said, well, we just don't know. And that shows again, I think in some of the survey data, that when you go ask employers, are you hiring four-year ET graduates, they're listed as an engineering person, or their title is engineering. Catherine talked a little bit about the comparisons of the curriculum. And if you look at a typical four-year ET curriculum, which is on the right side, and the engineering on the left, you'll see a lot of similar topics. That first one under science. Chemistry 1, you'll see down in that third item on engineering technology, they're taking principles of chemistry. I'll ask the question, what do you think is the difference? Starts with an M, and it's mathematics. It's back to the physics. When you look at engineering, which I have degrees in engineering, I had to take calculus-based physics. When you look at engineering technology, they tend to take more algebra and trigonometric-based physics. Same thing goes with mathematics. You look at an engineering degree, you've got Calc 1, Calc 2, Calc 3, differential equations, computational methods, and some math elective. In my case, it was partial differential equations, which I never used in my career. Engineering technology, you're looking at pre-calc, ET calculus, or an engineering analysis course, elements of statistics, engineering analysis again, how that application applies to it. And then when you look at laboratories, you see on the right side, engineering technology students are in the laboratory doing project-based hands-on learning from day one. When they come in as a first-year student, they're put in an applied curriculum and having to do something where engineering is working that way, but engineering technology tends to be working in a much more manufacturing, machine shop, get to know the processes and types of things. We talked a little bit briefly about the populations that are served. In the studies that we've looked at, and you can look historically, four-year ET degrees are awarded to African Americans 3 times of those earning engineering degrees. We're yet, and that's part of the findings and recommendations, is to understand why. But when you look at almost 11% versus 4%, there's something there that needs to be investigated. Hispanics earn approximately similar percentages of four-year ET degrees, 10%. And what we see in higher education is a shifting demographic coming, and that is the rise of Hispanics beginning to enter college age and graduating high schools. So That's something else in the recommendations we need to look at. But on the other thing that's most concerning are that women, Asians, and Pacific Islanders earn significantly less four-year ET degrees as compared to engineering. That exception, though, is African American women, which graduated with not a great percentage increase, but if I didn't put the percentage, just double what it is in engineering degrees. So, that